So in today's class, just to continue with one more problem of variance, then we go for some other theorem, some other theorem regarding the variances, right? So first we'll go for the one more example. I think we solved uh, three examples. The fourth example, consider the following distribution. Consider the following distribution, sorry, probability distribution probability distribution. So here they given some distribution of the particular random variable, that is x and p of x they given. So x can take the values 0, its probability is p, and 1, 2. So its value is 1 minus 2p. Then whenever x is 2, the value is p. They given one condition where 0 less than or equal to p less than or equal to 1 by 2. Next, for what value of p, for what value of p is the variance of x maximum, right? So given one distribution, and for what values of p our variance will be maximum. They are asking the about variance, right? So in the sense that by reading the question, obviously see, for what value of p the variance is maximum, it means that what our variance involved p value, right? So here we know that what we know, variance of x, right, which is denoted by variance of x, which is equal to expected value of x square minus expected value of x whole square, right? So this value involved p values. It involves the p variance of x in terms of p, right? So first we need to find out expected value of x. We know the formula, summation x into p of x. So this is nothing but 0 into p 0 into p plus 1 into 1 minus 2p plus 2 into p. So this is nothing but 0 into p, 0, plus 1 minus 1 into 1 minus p. So 1 minus 2p here. Sorry, 1 into 1 minus 2p. So that will be 1 minus 2p plus 2p. So 0 minus 2p plus 2p get cancelled. We got expected value of x equal to 1 here. Clear? So now here we found only expected value. Next we need to find out expected value of x square value. So this is equal to, we know that expected value of x square is summation x square into p of x. This is nothing but 0 square into p plus 1 square into 1 minus 2p plus 2 square into p. 0, 1 square will be 1, that is 1 minus 2p plus 4p. So 1 minus 2p plus 4p, this is nothing but around you will get minus 2 plus 2, 4. This is nothing but 1 plus 2p. So here we got expected value of x square equal to 1 plus 2p and expected value of x equal to 1. Just we insert in this variance formula. So expected value of x square 1 minus, sorry, 1 plus 2p, 1 plus 2p minus 1 whole square. This is nothing but 1 plus 2p minus 1. So minus 1 plus 1 get cancelled. We will get the answer p. Sorry, 2p. So variance of x equal to 2 into p, right? So what p lies between? P, they given in the question, p lies between minus, sorry, not minus, sorry, 0 less than or equal to p less than or equal to 1 by 2. It means that p lies between 0 to 1 by 2, right? So what they are asking, when your variance is maximum, right? So when this variance is maximum, whenever p value will be maximum, right? For example, right, for instance, put p equal to 0. So what about variance of x? 2 into 0 will be 0. Put upper limit, that is 1 by 2, put p equal to 1 by 2. So variance of x will be 2 into 1 by 2, that will be 1, right? So obviously, whenever p equal to 1 by 2, we have maximum variance, right? So for what values of p means p equal to 1 by 2 will be right? So whenever p equal to 1 by 2, it will have maximum variance, right? So this kind of example usually they are asking in various competitive exams. Next, we are moving. Okay, before that, anybody have doubt regarding this example? Indirectly, they are simply asking what will be the mean and variance, right? So directly they didn't, but indirectly they are asking what will be the mean and variance of this distribution. So I hope this example is clear. Next, we go for one theorem. Theorem, right? So first we go for statement. Statement. Let x be a random variable. Let x is a random variable with mean mu and variance sigma square. Then, so first one, variance of ax plus b, which is equal to variance of x. Variance of x means only sigma square. Second, variance of ax, this is equal to a square into variance of x. This is nothing but a square, as it is variance of x means what? Sigma square. Third one, variance of ax plus b, variance of ax plus b equal to a square into variance of x, right? Which is also equal to same a square into sigma square, which is equal to a square into sigma square, where a and b are any two constants, where a and b are any two constant, right? So here we are going to prove this theorem, right? So what the theorem says, if x is any random variable, it may be discrete, it may be continuous, right? It may be discrete or it may be continuous, and if it has mean mu and variance sigma square, then these following property holds good, right? So this first property, variance of ax, variance of x plus b, that is equal to only variance of x. Say for example, variance of x plus 2025, which is equal to variance of x only, right? Because a and b are any two constants, it neglects the constant. Next, variance of 3x is nothing but it is form of ax, so it will be equal to 3 square into variance of x, or 9 into variance of x. Next, third one, this is first one, second one, then third one, variance of ax plus b. Say for example, variance of 3x plus 2025, which is equal to a square, means instead of a to a, what we have? 3 square into variance of x. This is nothing but 9 into variance of x, right? So like this, we have the properties, right? So now we are going to prove these properties. Right? So now we are going to prove. So proof of first one, proof. The first one. So what says? We need to prove what we have? Variance of x plus b is equal to variance of x. We need to prove, right? So here we consider the definition of variance, right? By definition of variance. So what we have, the definition of variance, expected value of x minus expected value of x whole square, right? So this is nothing but what? Variance of x. Clear? So here, instead of x, what we have? Instead of x, we have x plus b, right? So variance of x plus b we have. So expectation as usual, instead of x what we have? X plus b minus, instead of expected value of x, that is nothing but expected value of x plus b. So just we consider the definition of variance. So expected as it is. So x plus b. So we know that this will be expected value of minus x, I mean minus expected value of x plus expected value of b, that will be b itself, right? Which is equal to whole square. This is nothing but we shown that expected value of x plus b is equal to expected value of x plus b, like this, right? So now expected value of x plus b minus mu. Why it is mu? Expected value of x equal to mu, they given. So what they given in the question? X is a random variable with mean mu. So expected value of x is mu, they only given. So here it will be mu plus, sorry. Here it is minus now outside, so it will be minus here. Right? Because it is like this, minus expected value of x minus b, right? When you multiply minus inside, so minus b whole square. This plus b minus b get cancelled. Now what we have? Expected value of x minus mu whole square. The meaning of x minus mu, this is nothing but expected value of x. Mu is nothing but expected value of x whole square. So again we got the variance of x definition remains. So here it is variance of x we proved, right? So it means that variance of x plus b is always equal to variance of x. Clear? So this is the first proof. Now second one, variance of ax, right? So here again use the definition. So what we have definition? Variance of x definition, expected value of x square minus expected value of x whole square. Instead of x, what we have? Ax. So it will be, sorry, before this, we have that one more definition. expected value of x minus expected value of x whole square. So instead of x, what we have here, ax. So it is equal to expected value of ax minus expected value of ax whole square, right? Which is equal to expected value of ax as it is. So when we multiply expectation inside, so this will be minus a into expected value of x whole square. So expected value of ax minus a into expected value of x is mu whole square. So expected value of here common is a, x minus mu whole square. So it is a is there, a is a constant, but it is a square. So when we take outside constant, it will be a square into expected value of x minus mu whole square. So this is nothing but a square into variance of x, right? So we proved that we proved that variance of ax is always equal to a square into variance of x, where a and b are any constants here, right? So this is what the second proof. Third proof, that is variance of ax plus b is equal to what? It is also same, a square into variance of x. We are going to prove this. So here again use the basic definition, right? So what basic definition says, variance of x equal to expected value of x minus expected value of x whole square. So here instead of x, what we have, ax plus b. So this is equal to expected value of ax plus b minus expected value of ax plus b whole square, right? So now expected value of ax plus b, when we imply the, I mean, when you apply the expectation inside, so it will be minus a expectation of x minus expectation of b whole square. So expected value of ax plus b minus a into expected value of x minus b, because expected value of constant is same constant. So expected value of ax plus b minus a mu minus b whole square. So again plus b minus b get cancelled. So expected value of ax minus a mu whole square. Again a is a common. So expect equal to expected value of a into x minus mu whole square. So it is inside the square. So when you take outside, it will be a square expected value of x minus mu square. So this is a square expected value of x minus expected value of x. I will take mu as expected value of x. So this is nothing but a square into this term is nothing but variance of x. So what we proved? We proved that variance of ax plus b is also equal to a square into variance of x, right? So we shown this. Clear? So this is what the proof. So here just our fundamental concepts are nothing but only the basic definition of the variance, right? So if you clear or if you know the basic definition of the variance, you can solve easily of these three sub theorems, right? So now I hope it's clear, or if you have any doubt, you can ask. Okay, now the next is standardize a random variable, right? Uh, a small concept, that is standardized random variable, right? So what do you mean by standardized random variable means? Just I will explain here. If x is any random variable, right? If x is a random variable with mean mu and variance sigma square, with mu and variance sigma square respectively, then using this x, suppose I will create one more random variable, say y, in such a way that x minus mu divided by sigma. Sigma is nothing but standard deviation, and this mu is nothing but expected value of this x, right? So then not only this, then suppose we got expected value of y is equal to 0 and variance of y equal to 1, then we say this y is nothing but standardized variable, right? So this y is nothing but standardized variable. Clear? See, let x be any random variable, let x be a random variable with mean mu and variance sigma square. Then a new random variable, then a new random variable, that is y equal to x minus mu divided by sigma, such that expected value of y equal to 0 and variance of y equal to 1, then y is called standardized random variable. Then y is called standardized random variable, right? So it's very simple. Here just we are going to define a new random variable, say that is y, in the form of whatever I display here, that is y equal to x minus mu divided by sigma, right? So then after that, we need to find out the mean and variance of y. Suppose we got mean equal to 0, right? Suppose we got mean equal to 0 and variance equal to 1, then we say that y is a standardized random variable, right? So depending upon this concept, we'll solve one example here. So now we'll enter into solved examples. First one, the mean and variance of the mean and variance of marks in statistics. Say example, for example, you consider as x will be marks in statistics. So marks in statistics as x are 60 and 25 respectively. Next, find mean and variance of, then find mean and variance of first case, that is y equal to x minus 60 divided by pi, then second z equal to x minus 50 by 10, right? So we need to find out the mean and variance of y here, right? And they what they given? They given mean of x. Mean of x is 60 and variance of x is 25, right? So now, what they given? Okay, given that expected value of x, that is 60, that is nothing but mean, which is equal to 60, and they given variance of x. What is variance of x? That is 25, right? So first we'll solve, that is y equal to x minus 60 divided by 5. Then what they're asking, mean and variance of these distributions, right? I mean these variables. So first, expected value of y. Okay, expected value of y is nothing but x minus 60 divided by 5. Clear? So this is nothing but we have the properties. We know that expected value of ax is nothing but a into expected value of x. So here a is 1 by 5. So I will take 1 by 5 outside. Then remaining thing will be expected value of x minus 60. Right? Again, we know that expected value of which one, that ax plus or minus b is equal to a into expected value of x plus or minus b. So instead of a, what we have here 1, and instead of minus b we have minus 60. So this is nothing but expected value of y is nothing but 1 by 5 as it is. When you multiply expectation inside, expected value of x minus 60, right? So expected value of y equal to 1 by 5. Expected value of x is given. Which one? That is 60 minus 60. So mean will be 0. Now similarly find out variance of y. Variance of y is equal to variance of x minus 60 divided by 5, right? So here variance of ax is nothing but a square into variance of x. So instead of a, what we have? 1 by 5. Again 1 by 5 whole square. So variance of x minus 60. So this is nothing but 1 by 25 variance of x minus 60. So this is nothing but 1 by 25, clear, into variance of x, right? Only. Why? Because we know that this which property, that is variance of x plus or minus b is nothing but only variance of x, right? So this is nothing but variance of x. What they given? Variance of x is also 25. Okay, 25 divided by 25 get cancelled, we will get 1, right? So expected value of y is 0 and variance of y is 1, hence y is a standardized random variable. Clear? Similarly, we are interested to find out the expected value of z and variance of z. So second, so z equal to x minus 50 divided by 10. Apply the expectation operator here, expected value of z. So 1 by 10 outside. So expected value of x minus 50. So this is nothing but 1 by 10 expected value of x minus, sorry, expected value of x minus 50. This is 1 by 10. Expected value of x is given, that is 60 minus 50. So expected value of z equal to 10 by 10, which is 1. Next, variance of z, which is equal to what we have here, here. So variance of x minus 50 by 10. So it is 1 by a format. So it will be 1 by a square. So this is nothing but 1 by 100 variance of x minus 50. So this is nothing but 1 by 100 variance of x minus variance of 50, but variance of constant is 0, hence it is only variance of x. So variance of z equal to variance of x divided by 100. So variance of x is given, that is 25 by 100. So this is nothing but 0.25. All right. So here completely we are using these properties. Which one? These properties, right? So it means that here variance of corollary we can write. So here variance of x minus b is also equal to variance of x itself, which is equal to sigma square, right? So here, as a corollary, you can take variance of x by a is nothing but 1 by a square variance of x, right? So likewise, you can take here, you can take 1 by x by a minus b also, that will be 1 by a square into variance of x. Like that, you can take, right? So this is what the concept of variances with some few examples, right? So here, out of y and z, y is the only variable which is standardized variable because its mean is 0 and variance is 1. But what about variance and expected value of z? Variance of z is 0.25, but expected value of z is 1, which is not equal to 0. Hence, we say that z is not a standardized random variable. Clear? Okay, now, we have one more remark here. Depending upon that remark, we are going to solve the next example. I mean, a remark or note, right? Suppose I define new variable if y equal to ax, right? Where a is any constant, where a is any constant, right? So then standard deviation of y is equal to modulus value of a into standard deviation of x, right? So this is nothing but what? Sigma y is nothing but what? Standard deviation, right? Standard deviation of y. And sigma x is nothing but what? Standard deviation of x, right? So depending upon this note, we have the next example, right? So if x is any random variable with variance sigma square x and standard deviation sigma x, then standard deviation of y is nothing but modulus value of standard deviation of x. Say for example, right? So if x has 9, x has variance, if x has variance equal to 9, then what will be standard deviation of y equal to minus 3x? Such type of examples will be created by this uh, note, right? So we know that standard deviation of y equal to modulus value of a into standard deviation of x. So standard deviation of y is modulus value of 3. This is nothing but minus 3 modulus value. Then sigma x. Sigma x is nothing but what? Standard deviation of x. But here they given variance. Right here they given variance. We know that standard deviation equal to square root of variance of x. Right? So modulus value of minus 3 will be 3. Square root of 9. This is also 3 into 3. Answer is 9. Like this note will report. Next, we go for the example here. Example, a random variable x, a random variable x assumes n values, it means that it takes the n values, say 1, 2, 3, and so on up to n, with equal probability, right? It means that what is the probability of getting x1 means that is 1 by n. What is the probability of getting x2 means that is also 1 by n. Like that, it has equal probability. Then, if the ratio of if the ratio of variance of x to expected value of x is equals to is equals to 4. Next, they continue the question. Find the value of n, right? Whenever the variance of x, I mean ratio of variance of x to expected value of x, and it is equal to 4, then find the value of n. Then they continue the question again. What will be the value of n if variance of x equal to expected value of x, right? So what will be the expected value of x equal variance of x? Then n value, right? So given question is very simple, but after reading it may feel complicated, right? So what they given? They given probability distribution here, right? So answer, what they given? A random variable x has the values 1 to n. It means that what? So x has the values 1, 2, 3, and so on up to n. Then with equal probability. So equal probability means 1 by n, 1 by n, 1 by n, and so on. It is also 1 by n, right? So this is up to here. Then what are they given? If the ratio of variance of x to expected value of x means what? Variance of x divided by expected value of x, it is equal to 4. They given this ratio. Then what is the n value? We are going to find it if this exists. This is first problem. Second problem they given, what are they given? If variance of x equal to expected value of x, then what will be the n value, right? So we need to find out n value in two cases, right? We need to follow n value in two cases. One is this ratio is equal to 4, then what will be the n value? And whenever this is equal, what will be the n value, right? So this is what the given probability distribution. So now for that, we go for finding the expected value of x, right? So this is nothing but x into p of x. Already we know that this is nothing but 1 into 1 by n plus 2 into 1 by n plus 3 into 1 by n plus and so on up to n into 1 by n. So obviously here 1 by n is common, then remaining things are 1 plus 2 plus 3 plus and so on up to n. So this is nothing but 1 by n. So this is what? Sum of n integers, right? So here sum of sum of first n integers equal to what? N into n plus 1 by 2, right? N into n plus 1 by 2. This is what sum of first. This is what this is equal to n into n plus 1 by 2. So into n into n plus 1 whole divided by 2. This n get cancelled. So now what we'll have? So we got n plus 1 divided by 2. N plus 1 divided by 2. What is this? This is nothing but expected value of x, right? Next, we need to find out variance. So for that, we go for expected value of x square also. So this is nothing but formula summation x square into p of x. So this is nothing but 1 square into 1 by n plus 2 square into 1 by n plus and so on up to n square into 1 by n. As usual, 1 by n is common, then 1 square plus 2 square, 3 square, and so on up to n square, right? So 1 by n. So sum of square of first n natural number, right? Sum of squares of first n natural numbers. So here also not integers, it is natural numbers. Natural numbers, which is equal to, these are what standard formulae. This is equal to n into n plus 1 into 2n plus 1 by 6, right? So this is nothing but n into n plus 1, 2n plus 1 by 6. So this n get cancelled. What do we have? N plus 1, 2n plus 1 by 6. Right. So this is what expected value of x square. So now to find out variance of x equal to expected value of x square minus expected value of x. So expected value of x square, what we got? N plus 1, 2n plus 1 by 6 minus here expected value of x whole square. So expected value of x whole square is n plus 1 by 2 whole square. So this is equal to n plus 1 into 2n plus 1 by 6 minus n plus 1 whole square by 2 square, that will be 4, right? So this is nothing but n plus 1, 2n plus 1 minus, so obviously it is 4 times of this term, entire term, minus 6 time of this entire term divided by 24 will be LCM, right? So now when we apply this formula and multiplied by 6, here we will get some, here first multiplied by 4 inside, 4n plus 4, right? Otherwise first we will take this so now n into 2n, so that is 2n square plus n plus 2n plus 2, so which is multiplied by 4 minus 6 as it is a square plus b square formula. So n square 1 square plus 2 times of ab, so that is nothing but 2n divided by 24, right? So now this is equal to 8n square. When you multiply this 4 inside, so it is 8n square plus 4n plus 8n plus 2 minus 6n square minus 6 minus 12n divided by 24. 8n square, 6n square get cancelled, so we have 2n square. See here 4n plus 8n, that is 12n. This 4n, 8n, 12n minus 12n get cancelled. So now plus 2 minus 6 by 24. This is 2n square minus 4 divided by 24. This is nothing but when you take 2 common, 2 into n square minus 2. 2n square minus 4. Okay. So this is 24. So this is nothing but n square minus 2 divided by 12. Right? Clear? So this is nothing but we can split n plus 1, n minus 1 by 12. Right? You can cross check also n into n square, then minus n plus n, 1 into 1 minus 1, that is minus 2. So n square plus n minus 2, so get cancelled, we'll get the same, right? Is it clear? So this is nothing but what? Variance of x. Next, this is what? Variance of x. So what they given in question? They given first, that is the ratio. Variance of x equal to, sorry, ratio variance of x divided by expected value of x will get 4. What is the variance of x? We have n plus 1, n minus 1 divided by 12 whole divided by expected value of x, n plus 1 divided by 2, which is equal to 4. So this is n plus 1, n minus 1 by 12 into 2 into n plus 1, which is equal to 4. So n plus 1, n plus 1 get cancelled. 2 1s are 2, 6 are 12. So here what we have? So n minus 1 by 6 equal to 4. So n minus 1 equal to 24, right? So n equal to 24 plus 1, that is n equal to 25. So whenever variance of, ratio of variance of x to the expected value of x equal to 4, then we have n equal to 25. Then we have one more case, second half of the answer. What is the second half of the answer? What they given? Uh, they given that if second half, if variance of x is equal to expected value of x, right? So variance of x, what we have? N plus 1 into n minus 1 by 12 equal to n plus 1 by 2. If this exists, then what will be the n value? So n plus 1, n minus 1. So this n plus 1 downwards. So it is n plus 1, which is equal to, I'll take 12 this side. So 12 by 2. This n plus 1 get cancelled. N minus 1 equal to 6. So n equal to 6 plus 1, that is 7. Right? So in this way, we can find out the n value for two different cases. Right? So we go for next example. Next example. Any doubt? Okay, let x be a discrete random variable. Let x be a discrete random variable with mean equal to 5 and standard deviation, estimated standard deviation, that is 3. Next, compute mean and standard deviation of first one, that is 2x minus 5. Second one, 3 minus 7x. Third one, x plus 1 by 2. All right. So it's very simple and easy example, this one. So what they given? They given expected value of x. Expected value of x equal to 5. And they given sigma x, not sigma square. Sigma square means variance, but they given what? Standard deviation. This is 3. So now what they are want? They want expected value of these. So here, first one, y equal to 2x minus 5. Let us assume. So expected value of y equal to expected value of 2x minus 5. This is equal to 2 into expected value of x minus 5. So expected value of y is nothing but 2 into expected value of x is given, that is 5. 5 minus 5. It means that 10 minus 5, which is equal to 5. Next, what they want? Sigma square y they want. Right? Sorry, not sigma square, only sigma y, because it is standard deviation they want, not variance. Standard deviation means what? Sigma y they want. So I told you, if what do you call that? Y equal to x, then standard deviation of y equal to modulus value of sigma x. Right? So here, what is the a value? A value is 2. See, whatever the minus 5, like here 3, those are not applicable here, right? So this is equal to modulus value of 2 into standard deviation of x. So 2 standard deviation of x is 3 into 3, which is equal to 6. Clear? Next. Second one, let us assume z equal to 3 minus 7x. So expected value of z equal to expected value of 3 minus 7x. So expected value of z equal to 3 minus 7 into expected value of x. So expected value of z equal to 3 minus 7. Expected value of x is given, that is 5 into 5. So 3 minus 35, which is equal to 32. Expected value of z. Right. So expected value of z equal to 32. Next. Now we want sigma z. So this is nothing but again modulus value of sigma x. So here sigma z equal to modulus value is minus 7 here. Minus 7 sigma x. See, plus 3 minus 3 doesn't matter. I mean, not applicable for variance. It is applicable for only expectation concepts. So variance not applicable means standard deviation is also not applicable. Equal to 7 into sigma x is nothing but they given, that is 3. Right? So sigma z equal to 21. Clear? Next, third one. That is x is completed, y z. Okay, let us consider w. W equal to x plus 1 by 2. Then expected value of w equal to expected value of x plus 1 by 2. This is nothing but 1 by 2 expected value of x plus 1. So this is equal to 1 by 2. Expected value of x is 5 plus 1. So this is nothing but 6 by 2. That will be 3. This is expected value of w. Next, standard deviation of w, which is nothing but sigma w. So sigma w equal to modulus value of a into sigma x. Right? So here sigma w equal to modulus value is 1 by 2. Right? So modulus value of 1 by 2, sigma x is, that is 3. So answer is 3 by 2. Clear? So these are what the some few different examples rather than your practicals. So you need to concentrate on such examples also which are applicable. I mean applicant orientation. Applicable orientation of these properties of variance concepts. Right. So here this is the today's class. So just we'll take a quick revision of today's class. So what we have? So we left with one example, that is when variance of this x will be maximum for what value of p. So we solve this example, right? After that we come across such theorem. We have some sub formulae here. So we come across proofs of these theorems. After that we have we discussed on standardized random variable. After that, one example we solved regarding standardized variable example, this example. After that, we discussed one point, that is this one. After this, we solved some special kind of examples like this, right? So although if you have any doubt, you can contact me in the department tomorrow, right? So the expected value can be negative. Yes, you can get negative also, but variance never negative. Expected value may be negative, but variance it's never negative. Sir, but in that second problem where you taken z, you have written 32. That answer should be minus 32. Here, hi. Oh, yes, here it is minus 32. Sorry. 3 minus 35, it is minus 32. Clear? Yes. Yes, sir.